Bismillahirrahmanirrahim. Today I wanted to talk about the concept of slope in a Cartesian plane. So you have these three mountains over here. Let's imagine that you wanted to climb these mountains, and you first wanted to pick which mountain to climb. And besides the fact that the one in the back is the tallest, but that's one thing. But there's also another difference between these three mountains, of course, and that is some of them are steeper than the other one. That is, they would be harder to climb. This mountain, the one that's all the way in the front over here, for example, like let's just say from here to here, it seems like should be a reasonable climb, right? If you're going from here to over there. So climbing this front mountain from going from here to here, and that doesn't sound so bad. But let's say if you were climbing this other mountain over here, and you're going from here to like over there, and that seems like a little more challenging climb, right? Because it's a little steeper, and you'll be a little bit out of breath. Then on the other hand, if you were climbing this mountain over here, that seems like a whole different thing, because that's like going from this way to that, and that's much steeper, and that seems like a much difficult climb. And that precisely is the concept of slope. The concept of slope is steepness. So in a way, you can say slope of a particular mountain here is how steep it is, right? And that's precisely how we define slope in the Cartesian plane. Now, if you were to mathematically say, okay, well, I get it. The mountain in the back is steeper than the mountain in the front. It'd be harder to climb because you're going like more straight up. So the more straight up a mountain is, right? The more straight up a mountain is, it seems like it'd be much harder to climb. So this, for example, mountain was like that'd be like, whoa, super hard mountain to climb, correct? So that's the concept of steepness. But how do you define it precisely in a mathematical sense? In other words, how much more steeper is this mountain compared to this brown mountain, for example, right? So by how much more? So how do we compare this steepness to this steepness to that steepness in a mathematical sense? Is it twice as more steep, or 3 times or more steep, etc.? So in a mathematical sense, if you understand, we can say the steepness is like, okay, well, it seems like steepness is like how far you have to, how much gain you make for every number of steps you take in this direction, correct? In other words, you take a lot of steps in this direction, you take a lot of steps in this direction, but you don't take that many steps in this direction, correct? So you take a lot of steps here in the x direction, let's put like this, and you don't take compared to that, you don't take that many steps in the y direction, correct? Compared to this, let's just go with the yellow one here. For the yellow curve, you take this many steps in the x direction, and then compared to that, you take way more steps in the y direction, right? So the steepness, in a sense, is the comparison of how many steps you take in the x direction to how many steps you take in the y direction. The more steeper it is, you take way many steps in the y direction compared to the number of steps you take in the x direction. So that is the fundamental concept of steepness, or slope as we define it in mathematics. The number of steps you take in one direction and compared to the number of steps that you take in the other direction, in changing x and changing y. So this symbol, of course, here, the triangle, is not really a triangle, it's delta, it's a Greek letter delta, and that represents that's the capital delta, Greek letter, and that represents the phrase change in. Okay, so formally we define slope in the Cartesian plane as, and we use the letter m for slope, the change in y compared to the change in x. In other words, how much you climb for every steps that you take in the x direction. And the bigger the change in y is compared to the change in x, then the steeper the slope is. And this is in the mathematical, so you can actually define is like 2 times as more steep, and 3 times more steep, or 4 times, whatever, more steeper, because now you have precise numbers that you can compare. So slope, in a way, is steepness based on how many how many steps you take in the y direction, so to speak, compared to the number of steps that you take in the x direction. So this is a very important understanding of the concept of slope. The other aspect of the concept of slope is, of course, going this way is one thing, but going the other way, like if you were to climb down, I mean, it's like you can have the same concept, right? Coming down over there versus coming down over here, like a little mini coming down over there, has different steepness as well. So there's steepness going this way and the steepness going this way, correct? So you can talk about, okay, steepness like this coming down like that too, right? So that we can also work out in mathematical fashion, because then we can say any slope that's going this way, any line that's going this way will have a positive slope, and any line coming down like in this way, we can call that like negative slope going this way. So this would be negative slope, and going to the right, going like this way, would be a positive slope. Okay, so those are the basic conceptual ideas as they relate to slope. Okay, so let's take an example in the Cartesian plane. I have two set of ordered pairs over here. We can name them if you like. Let's call this one point A and this one point B. So in slope, if you recall, that is the change in y over change in x, and in ordered pair sense, we can say y2 minus y1 over x2 minus x1. Okay, now it doesn't really matter which one is x1 or x2, but they x1, x2, and y1, y2, they represent ordered pairs. So you can say this is x2 and y2, and that's the first ordered pair. You can call this one x1 and y1, like this. So for any given ordered pair, in this case I've picked this ordered pair and this ordered pair, point A and point B, and you can represent them theoretically as x2 and y2 and x1 and y1, and the slope is defined as the change in y over change in x. Now if you were to just simply consider this as like mountains, like if you from one point in a mountain to a second point in a mountain, you can think of this as, okay, going in this direction like this many units, right? And then they are going in this direction like this, right? So if this was like a slope in a mountain, we can pretend it's the mountain again, and we can just call this, okay, let's say this is a mountain, and this is the segment that you're climbing on the mountain. So, and then you can say, well, this is the change in the y direction, and this would be like the change in the x direction here. From here to here would be the change in the x direction. Let me just write that change in the x direction like this. Okay, now the slope therefore is how many steps one takes over here in the y direction and compared to how many steps that you take in the x direction. Now if you can just count it, that's pretty easy enough, in fact, if you can just count the boxes, right? So if you say that this is change in y, you can just say how many boxes is that. It's 1 box, 2 box, 3 box, 4 box. So you can say the change in y here is simply 4 boxes. And then in the x direction, if this is from here to here, that's like the change in x. Okay, the change in x here is 1 box, 2 box, 3 boxes. So change in x is 3. Okay, so you can visually calculate the slope. You don't have to use this formula per se. So from a purely visual sense, the slope here is going to be change in y. Let me use the green color over here. The slope here is going to be the change in y, right, over change in x, and the change in y is 4 boxes. For every change in x, which is 3 boxes here. So the slope is 4 over 3. Okay, that's pretty easy enough to do that, right? So change in y over change in x is 4 over 3. So, and from a visually, you can figure out how to do that. But if you wanted to use the mathematical formula to calculate the slope, well, that's not that difficult either. So you can say, okay, the slope is going to be y2 minus y1. Okay, so this is y2. Okay, so y2 is over here 2. Okay, so that's 2. Okay, and then there's minus y1 is negative 2. You have to be careful here because the y1 is negative 2 over here. See, you have to be careful with this, with the negative sign. So because small kids, they make mistakes over here because they kind of mess up the negative signs, because there's a negative sign here that belongs to the equation of this, the formula for the slope, and that's this negative sign over here. And then there's a negative sign that belongs to the number itself, which is negative 2. So you have to be careful with negatives. So that's probably the most common mistakes that the students make, that they mess up with the negative sign. So you have to be careful and methodical and not fall into the trap that that's commonly made by for students. Now, so the change in y, 2 minus negative 2, and the change in x, of course, is here the x is going to be 1, and this x is again minus negative 2. So that's negative 2, minus, let me put that for the sake of consistency, minus negative 2 like this. All right, now you can simplify this, so you can negative give it positive, and that's 4, and negative will make it positive, that's 3, and of course that's the same answer that we got over here. So in the first drill, we just kind of looked at it because the points were kind of falling nicely, and we just calculated the boxes, the change in phi for every change in y over the change in x, and that gave us the slope. And then we used the formula, the change y2 minus y1 or x2 minus x1 to calculate the slope. Now, in this case, the slope was positive, and that was pretty easy enough to calculate. Now, let me give you another example to make sure that we get the signs correctly for the slope. All right, so here I have a whole bunch of points, or 5 points at least, that I have drawn in the Cartesian plane, and we're going to calculate the slope simply visually. So let's calculate the slope between A and E. So in the segment AE, all right, let's calculate the slope of segment AE. Okay, so the slope here is going to be change in y over change in x, okay, like this. Now, if you were to draw out the segment AE, it would be like this. And we have to remember that segments or lines that go this way, they will have a negative slope, okay? Because for every change in y, that y is going to be a negative numbers, okay? So for every change in y, it's going to be like this. So you're going down in y. So from here to here, the change in y. So that's the change in y, and that's going to be like the change in x, correct? But we have to understand when you're going down like this, this is going to be negative. So you're going down 1, 2, 3, 4. So that's change in y is actually 4, and that's going to be negative. If you just understand anything that goes this way is going to have a negative slope, okay? So that's going to be a negative 4, and the change in x is going to be, okay, 1, 2, 3, 4, 5, and that's 5. So you can visually calculate slopes like this, okay? And so you don't always have to use the formula. It's easy to do over here like this. Okay, so let's do another one. So we got AE. Let's find the slope of AD over here like this, okay? So we have segment AD, and the slope of the segment AD is going to be, again, it's a negative slope. You're going down over here. You're not climbing the mountain. You're going down the mountain, so to speak. That's actually only one. So it's negative 1. So only one box down, right? Going down this way, and then going this way over here like this. So negative 1 and going this way over here. That's how many boxes? 1, 2, 3, 4, 5 boxes again. So that slope is negative 1/5. Okay, so that's easy enough. So let's calculate a few more slopes. Let's calculate the slope of BC here, segment BC, and then let's calculate the slope also of segment BD. So if you recall, slopes of lines or segment that go this way, they are positive, and slopes of line that go this way, they are negative. So BC and BD, they're both kind of going this way, so their slopes will be positive. So, and let's just do BC first. So for segment BC, the slope is going to be change in y over change in x like this, and that's the change in y. So from C to B, like 1, 2, 3, 4, that's 4 boxes. Change in y and change in x, 1, 2, 3, 4, that's 3 boxes. So that's 4/3. So the slope is change in y. If I were to draw it like this, that's going to be the change in y over here, and that's 1, 2, 3. That's 4 boxes, and the change in x going from B to C. That's 1, 2, 3. That's change in x. Did I do that correct? 1, 2, 3, 4. That change in x is also 4. 1, 2, 3, 4. So you have to be careful that you don't make the same mistake that I do, and always good to check, double check your work, isn't it? All right, so that proves my point. So anyway, so that's 4 over 4, and that slope is 1. That's interesting. So we got that done. Let's do BD. So for BD, the change in y is going to be this. So that's going to be change in y. So it says that's BD. All right, so that's BD. The slope is going to be change in y is going to be that's 1, 2. That's definitely 3. So that's 3. And then the change in x is 1, 2, 3, 4, 5 over here. That's 5. The slope is 3/5. And if you were to, this is as a decimal, is 0.6. You'll punch that in a calculator if you know that that's going to be 0.6. And here you see something interesting. The slope here for the first one, going from B to C, is steeper mountain to climb. The slope is 1. And clearly the number 1 is greater than 0.6. So and B to D is not as steep of a mountain climb, so to speak, so the slope is less. So here we have mathematical representation of a phenomenon of steepness, and that shows that clearly this is steeper than this. And of course these are very simple examples, but the difference might be much smaller, and so you can say the slope of one segment is 1.0, the slope of the other segment is 9.7. They're not the same. This is minusculely bigger than the other one, but you get an idea. The difference is not that dramatic. But here we have a visual representation of steepness, and this is 1 and this is 0.6. Okay, so that's easy enough. And then, but if you wanted to calculate these using ordered pairs, we can do that as well. So let's give the B its deserved ordered pair, 1, 2, 3. That's -3 and -2. And let's just do D over here. Give that its deserved ordered pair. That's 2 and 1. So let's do BD here and calculate the slope as change in y over change in x. And it doesn't matter which one you pick to be y1, y2, and x1, x2. So y1, x1, y1, and x2, y2. They just represent any particular points in a Cartesian plane. You can call x1, y1 to be b, or you can call x2, y to be b, and the formula will still work. You just have to be consistent. Okay. So all right. So let's do this. So for changing y over changing x using the formula. So here the y is 1, so it's 1 minus. Now this most common mistake kids make is to forget these negative signs or mess them up. So y2 minus y1, so this is minus, and this -2 over here. So you have to be careful with that -2, because this negative sign belongs to the number over here, like that. Okay, and this negative sign belongs to the formula. So be careful with the negative sign, so you don't make those silly mistakes. So that's 1 minus -2, like this. And then so y2, that's this, minus y1, like that, and x2 minus x1, that's 2 minus, and again be careful, there's a -3 over here, -3 over here, and you can simplify this. Minus will give you plus, so that's 3, and minus will give you plus 3 over 5, and that's precisely what we got over here. That's 0.6 if you wanted to. You can leave the slope as this, and let's just actually, so because you don't have to put it in a decimal form. So here's 3/5 and here's 3/5. So we got the same answer, just eyeballing it, so to speak, just counting the boxes and using the formula. Now, the counting the boxes will only work if the boxes are kind of nice and neat. But if it was a point like this over here and a point like that over here, this is like -2 and like 2.143. And this point over here is like 1, let's say 1, 2, 3, so like 3.48 and 2, 3, and 3.74. It's much harder if you have decimal points and things like that, but then you can use the formula and calculator to help you out or something like that. So in those cases, formulas are easier. But if you're given a simple problem where you can see the ordered pairs, you can just calculate count the boxes, so to speak, in finding the slope. But you can always use the ordered pair, of course, to find the slope as well. Just remember, segments and lines that go like this, they have positive slope, and segments and lines that go in this direction, they have a negative slope. Alright, so before I finish, there's one more thing that I wanted to talk about, and that is the slope of horizontal and vertical lines. So let's do that. Let's calculate the slope of, okay, this looks good enough. Let's calculate AC over here. So for AC, for segment AC, we're going to try to calculate the slope, and that's a horizontal line. So same thing though, the formula still applies. So change in y over change in x, okay? So the change in y is the change in this direction. Well, you're not going in any up and down at all. You're just going horizontally, right? So basically zero. That's zero. There's no change in y. You're just going horizontally straight. And the change in x is, let's say, 1, 2, 3, 4. That's 4 boxes. But 0 divided by 4 is just 0. So here we learn that the slope of horizontal lines, okay, so horizontal line segment is going to be 0. So that's very, very important to understand. The slope of horizontal lines is 0. Okay, that's fair. That's always going to be, because there's no change in y. The change in y is 0. Okay, how about this one? How about if we go vertical lines? How about, let's say, AB over here? Let's find the slope of AB. So we have segment AB. Okay, so you have AB, segment AB. The slope is, again, going to be change in y over change in x. So, okay, here we have a change in y. Okay, let's see. 1, 2, 3, 4, 4 boxes. But there's no change in x going from A to B. You're not moving in the x direction at all. And so the change in x is 0. But division by 0 is not defined mathematically in logical incongruency, so it's actually not defined. So this is undefined, D-E-F-I-N-E-D, undefined. So the slope of vertical lines, it's like infinite slope in a way, and because it's so steep, right? But the slope of vertical lines is undefined. Okay, so these two facts you have to know, that the slope of all horizontal lines is 0, and the slope of vertical lines is undefined. So now, so today we talked about the concept of slope and how to find slope in the Cartesian plane, just visually by counting boxes, and also using the slope, the formula for the slope, which is change in y and change in x. Before I finish, I just want to bring to attention, as simple as these problems, I've done probably over thousands of these, and every time I do it, I'm methodical. I write down this, at least to remind I don't make silly mistakes. And the most common silly mistakes that students make are with these signs, and they end up with the wrong answer because they made a simple computational mistake because they forgot the negative sign. So it's always useful to at least write this formula when you're doing the problem, to remind yourself that to be methodical and careful with the signs. Inshallah, we shall develop on this next time. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.